Before we move on to the creating of the address structure, we need to know about another concepts, because it's time that we enter some addresses and some data. This concept is endianness. Endianness is the method of the processor that reads the data. So let me actually show them to you in action. So I press Ctrl Shift and T, and let's say that well, there are a lot of data types that are multiple byte values. For example, integer, we know that it is encoded in many systems using 4 bytes. For example, let's say that we have a 4-byte value or a word which is equal to 0x in the hexadecimal representation 1 2 3 4 5 6 7 8, and this is the 4-byte. Now there are two methods of saving this data in different architectures. One of them is called the little endian, the other is big endian. In the big endian format, when this value is going to be saved, it would be saved in the same format. So we would have 0x12 would be in the smallest unit, the smallest address would be 0x12. For example, let's say that we want to save it in the addresses, in the cells with the address of 0 to 3. So this would be saved in the address 0. 0x34 would be saved in the address of 1. Then we have 0x56, which would be the next byte, and 0x78 would be in the address of 3. As you see, the most significant byte would come first or in the smallest address. In the second case, that would be the little endian. Of course, in the big endian, when the data wants to be read, again, the processor would load them as you see in here. The smallest would be 0x12, so we would have 0x12, 3, 4, 5, 6, and 7, 8, and you would have the original word that you see in here, the original 4 bytes in here. But in the second method is the little endian format. In the little endian format, the least significant byte in here, actually I think I said bit in the previous sections. Okay, the least significant byte or 78 would come first. So we would have 0x78 at the first address, then we would have 0x56 at the second address, 0x34 at the third address, and 0x12 or the most significant byte would be at the biggest address. And this would be the method of saving data in a processor which works with the little endian format. Now when the data wants to be read, then again in the little endian format it would be read. So first we would have 0x12, 0x34, 0x56, and 0x78, which would be 0x1, 2, 3, 4, 5, 6, 7, 8. In both methods, as you see, the data that is saved and then loaded is equal to itself. So, but there in all the system, as you see, we won't have any problem. But when there is a communication of data, we would have a problem, because let's say that the source would work with the big endian format and the destination would work with the little endian format. Now in this case, you would have, of course, all the data would be vice versa. If the source and destination will work, they work with the different endianness, the data would be, of course, reversed. Now there had to be a universal method or endianness for this. So they said another concept was created, that the endianness in a computer would be called the host byte order. But then another format, a universal format, would be created called the network byte order, when there is actually a communication, where a communication is going to take place and some data is going to be sent. So in that case, that would be called network byte order, and the network byte order is always big endian. So whether a system works with the little endian or big endian, when it gets to the trading information, the byte order would always be big endian. Now considering this, when you want to go to and create our address structure, for example, we need to enter some port number, for example 4000 or 5000. Now we would have to convert that to the network byte order. If our system works with the big Indian already, then it wouldn't do anything. It wouldn't be doing anything. But if our system works with the little Indian, then the function would convert the representation from the little Indian to big Indian. So considering this concept, we would get to the next lecture when where we are actually creating our address structure.